Implicit differentiation. What is it? Today we're going to have a look. Implicit versus explicit. An explicit equation is the kind of thing you've been doing all the way up in maths until this point. That's where one variable is the subject of your equation. For example, y equals x squared plus 2. That's an explicit equation because it's y equals. It has one variable as the focus of its subject. Similarly, for y equals mx plus c, again, it's just y equals. There's one variable that is the focus of your subject. Now, these types of equations should be very straightforward to differentiate at this point. I hope they are anyway. A equals pi r squared is another example of an explicit equation. An implicit equation, on the other hand, is where all the variables are kind of jumbled up. There is no one that is the focus. So, for example, if we looked at 4xy minus 3x squared equals 20, it's not x or y that's the focus of that equation. They're all kind of jumbled together. Similarly, for the equation of a circle, and if we just make up one with logs and cos's and jumble up the x's and y's as well, these are all different types of implicit equations. These are the kinds of things you will be expected to differentiate in your A-level syllabus. Now, what we're going to do is differentiate these three equations. The first one should be very straightforward. We're going to differentiate both terms with respect to x. By now, you should be able to differentiate 4x cubed with respect to x. So we're differentiating d dx means differentiate with respect to x. And of course, you're going to end up with 12x squared. Now, what you've been doing all along, and you haven't realized it, is differentiating y with respect to x as well. If we d dx y, we get dy dx. If you differentiate y, you get dy dx. Now, we're going to differentiate 3y in this example too. First of all, 2x to the power of 9 should be very, very easy. 2 times 9 gives you the 18, and then x to the power of 8. If you differentiate 3y, differentiate y, and you get dy dx, and then there's a 3 in front of it, times it by 3. So differentiate 3y to the power of 1, if you think of it that way, is 3 dy dx. And we're going to try it with 5y cubed. If we differentiate this equation, now again, do the x part, very straightforward, multiply by the power, take away 1. So 101 times 4 is 404. Subtract 1, x cubed. It's basically the same thing with 5y cubed. Multiply by the power and take away 1. So 5 times 3 gives you 15. Take 1 from the power, y squared, and then write dy dx because we've differentiated y. Okay, now we're going to try and piece this together into an exam-style question. We're going to find dy dx of this equation. Now, when you're asked to do this in your exam, if you're finding dy dx, that's a fancy way of saying differentiate it and make dy dx be the subject of the equation. Now, to do that, of course, we're going to differentiate it first. If you differentiate 6y squared, you multiply by the power of y to get 12 and take away 1 from the power. And because we've done it with a y, we write dy dx. Similarly, for 3x, differentiating minus 3 is hopefully very easy for you at this point. If we differentiate 4y cubed, multiply by the power, and take away 1. So 12y squared, and then a dy dx because we've done it with y. And if you differentiate minus 2x squared, you should just get minus 4x. That bit's dead easy. Now from here, we want to make dy dx be the subject of the equation. So we're going to rearrange it. We're going to write all the dy dx bits on one side of the equation and move all the other bits to the other side. So I'm going to collect my dy dx terms on my left side of my equal sign. I'm going to move all the other little bits onto the right side. So I'm going to have 12y dy dx minus 12y squared dy dx equals 3 subtract 4x. Once that's done, you're going to factorize it. We're going to take out a common factor of dy dx. Now, this could be factorized further. We could take out a factor of 12y dy dx, for example, but don't do that. We're only interested in making dy dx be the subject of the equation. So that's the only bit we're removing from these things. The only common factor we're taking out. Put in what's left in a bracket and equals 3 minus 4x.
So our last step is to divide. We're going to divide across by that big bracket. And if we do divide across, then dy dx is all by itself, which is exactly what we're after. On the other side, you should have 3 subtract 4x divided by 12y minus 12y squared. And there's dy dx equals. Now we're going to try a slightly harder one. We're going to mix up the x and y terms so it looks like they're being multiplied together. So for example, 4 times x cubed times y to the 5. When this happens, when you've got two terms multiplied together, you differentiate this thing twice. Once thinking about the x term and then once thinking about the y term. If I differentiate thinking about the x term, basically you're differentiating 4x cubed. If you differentiate 4x cubed, you get 12x squared, and then you just write y to the 5 beside it. For the y term, you're essentially differentiating 4y to the 5. If you differentiate 4y to the 5, 4 times 5 gives you 20. Take away 1 from the power, you should have y to the 4. Because we've done it with respect to y, we write dy dx, and x cubed stays exactly as it is. It doesn't change. I'll make up another one. It looks harder because it's got fractions, but the method is exactly the same. 3x to the half, y to the minus a half. Differentiate it twice. First of all, differentiate 3x to the half. If you do that, you should have 3 over 2 x to the minus a half. And the y variable doesn't change. It's just y to the minus a half. Do it again, but this time differentiate 3y to the minus a half. If we differentiate 3y to the minus a half, you should have minus 3 over 2 y to the minus 3 over 2. There's also an x to the half in there that hasn't changed. And because we're doing it with a y in mind, we write dy dx when we're done. So each of these things you differentiate twice, once thinking about x, once thinking about y. If we put that into an exam style question, 7y squared, differentiate that, simply 14y dy dx. This next bit, 3xy squared, do it twice. Think about the x. If you differentiate 3x, you get 3, and then put in the y squared. If you differentiate 3y squared, you get 6y, and then put in your x and put in your dy dx. So 6xy dy dx in alphabetical order. And if you differentiate 4x, you just get 4. Now, since we're trying to find dy dx of this equation, we're going to do the same thing we did the last time, which is to rearrange it. We're going to keep all the dy dx bits on the left side of the equal sign, put everything else on the right side of the equal sign. So collecting my dy dx terms together, we should have 14y dy dx, take away 6xy dy dx equals 4 plus 3y squared. Moving the 3y squared essentially across to the right-hand side. As before, again, because we're looking for dy dx only, we're going to factorize the left-hand side, take out dy dx as a common factor, take out only dy dx and nothing else. So take out dy dx, open up your bracket, put in what's left, 14y minus 6y squared. Sorry, 14y minus 6xy. And that's going to equal 4 plus 3y squared. And then your final step is exactly as it was before. Make dy dx be the subject of the equation. So I want dy dx equals. We're going to divide across by that big bracket to do so. So 4 plus 3y squared divided by 14y minus 6xy. Sometimes at this point, you will find that your fraction can be simplified further. For the purposes of this video, I'm not going to bother doing that, just to keep it nice and short. I don't think this one simplifies anyway. Okay, we're going to try one final question. We're going to find the gradient function of x cos y plus e to the 2y minus 3 equals x. So, differentiating this first bit, it is two variables. There's an x and a y. So again, we're going to differentiate it twice. Thinking about the x term. If we differentiate x, we get 1. So just write cos y. Now I think about the y term and differentiate it. If you differentiate cos y, you get minus sine y. So we want to stick in our x with a 2, minus x sine y, and dy dx because we've done it thinking about the y term. E to the 2y only has a y term, so we differentiate it thinking about y, multiplied by the coefficient in the power, so 2e to the 2y dy dx. Differentiate 3 disappears, and if you differentiate x, you should get 1. Now, exactly as we've done with the previous two examples, rearrange the equation so that dy dx is your subject. I'm going to collect all my dy dx terms on the left-hand side exactly as before, collect everything else on the right-hand side. So it's basically just taking away cos y. So I've got 1 minus cos y on my right side. And as before with our next step, we want to take out dy dx as our common factor. Now you should find when you do these questions, finding the gradient function or finding dy dx, the steps are almost always the same. Differentiate it, rearrange it. And to rearrange it, it's collect the terms on each side, factorize, and divide. It's always that. So dy dx is going to be eventually 1 minus cos y divided by that large bracket, 2e to the 2y minus x sine y. Looks quite horrible, but sometimes they do. Sometimes, of course, you can simplify them as well. Sometimes. Hopefully you understand implicit differentiation a little better. Do feel free to click like and subscribe. Thanks for watching.